So, sketch y equals sine x minus cos x. Now, to begin with, that looks too difficult. I'd have to draw a sine and a cos and subtract them and try and figure out how to draw it. But I can actually convert this into a different form. So that's where I'm going to start. First, we're going to write sine x minus cos x as r sine x. And now I want plus or minus alpha. There's a minus here, so I'm going to go minus alpha. And I'm going to get my alpha to be in the first quadrant. So let's expand this expression. And this is what was meant when we talked about do it from scratch each time. Sine of a difference is sine cos minus cos sine. Sine x cos alpha minus cos x sine alpha. Yes, that's correct. So then I'm going to expand my brackets. R sine x cos alpha minus r cos x sine alpha. Equate coefficients. Sine x is r sine x cos alpha, which means 1 equals r cos alpha. And negative cos x has to be negative r cos x sine alpha, which means 1 has to equal r sine alpha. So, I instinctively want to do the divide first, right? 2 over 1 tells me 1 equals tan alpha. And that means alpha has to be pi on 4. And we're always working in the first quadrant, so it's just pi on 4. Now for the other one, I have to square them and add them. 1 squared plus 2 squared gives me, this squared plus this squared is 2, and this is r squared cos squared alpha plus sine squared alpha, which means it's r squared times 1, which means r is square root of 2. And we're only working in the positive section, okay, because we're only working greater than 0. And therefore y sine x minus cos x is the same as root 2 sine x minus pi on 4. Sorry, just realised I went just off the bottom there. So I've written my original function as a single sine. Now I should be able to sketch it. I'm not going to worry about making this perfect and getting my grid paper out. Y, x. Okay, amplitude is root 2, which is 1.4. So if I go 1, 2, negative 1, negative 2, and I'm going across to 2 pi, so that's 2 pi, pi on 2, 3 pi on 2, and I'm actually going to want the quarters as well. Pi on 4, pretty close, 3 pi on 4, 5 pi on 4, 7 pi on 4. Okay, the normal sine graph starts at 0. we've got an amplitude of root 2, and we've got a shift to the right of pi on 4. So it's coming up here. It's actually going to have its minimum at about 1.4 down here, over here. It's going to have its maximum here at 1.4. It's going to be going down here. Minimum here at minus 1.4, going back up. Now, what is the coordinate here? Well, the coordinate here is when x equals 0. So, when x is 0, why don't we actually solve that carefully? When x equals 0, root 2 sine 0 minus pi on 4 is root 2 sine minus pi on 4. Do you remember this? 1, 1 root 2 triangle, pi on 4. So sine is 1 on root 2. What's this negative sign going to do? Negative angles, sine is the y-coordinate, is negative. So it's root 2 times negative 1 on root 2, which means my y-intercept is actually negative 1. Well, that's easy to draw, isn't it? That means we're coming through here. We would have been coming from there. We're coming up through here, up to the top, back down through here, back down to the negative, and actually at 2 pi, it is also negative 1, going up through there. Let's label points of interest. These ones are already labelled, so that's okay. My maximum point is 3 pi on 4 root 2. My minimum is 7 pi on 4 negative root 2. And my y-intercept is labelled as negative 1.